Okay, so this is a concept that is supposed to be taught in math too. And it's one of those things that teachers like oftentimes run out of time when this comes at the end of the year. So I don't know if you've ever seen this before. You might have the most knowledge of this ever. You might never have heard these words before in your life. I feel like there's all different gambits of that in here. So I'm just going to teach it from scratch, but quickly. And that's okay because it's easy. First thing I'm going to do is grab 4 pens from my bag. You're like, what does that have to do with anything? It has to do with everything. Okay. And in this lesson, what we're doing is figuring out the number of possibilities for choosing different amounts of objects. So this is a probability type thing. It's very easy, don't worry. Okay, so the first thing I want to do is the most basic thing, and I want to talk about how many different ways can I arrange those 4 pens. Okay, so this is just extremely like the most basic thing. And do you notice that all of the pens are different colors? Guys? Do you notice all the pens are different colors? Okay, and you notice there's 4 of them. Okay, so I want you guys to imagine that I have 4 spots for pens. Spot 1, spot 2, spot 3, and spot 4. Okay, I have them in my hand. How many choices do I have for spot 1? 4 choices. Okay, now let's just say I put pink there. Okay, how many choices do I have left for spot 2? 3. Okay, and then I just pick one. Okay, how many choices do I have left for spot 3? 2. Okay, and then how many choices do I have left for spot 1? Okay, this is 4 times 3 times 2 times 1. That means I have 24 different ways to arrange my pens. Are you guys with me so far? Okay, that's called a permutation. Permutations are arrangements. So that's the first thing we're going to write on our paper. Permutations are, we're going to use a different pen. Luckily, I seem to be overloaded with the amount of pens. Okay. Now, there is a mathematical symbol for this math right here. I bet you some people in the room know what that is. Does anybody know the word or the symbol that represents this in math? Yeah, it's a factorial, and the symbol for it is the exclamation mark. So in this class, it's required that if you are doing a factorial, you have to scream. I'm sorry, I don't make the rules, I just enforce that. Scream. Because factorial, the symbol for it is exclamation mark. So that means I'm not saying 4, I'm saying 4. Okay, so 4 is not 4. 4 is 4 times 3 times 2 times 1. Okay, now I have just opened up a world of TikToks for you. There's a bunch of TikToks about like products that have like 4 new varieties. And is it 4 or is it 4 factorial? Because only the nerds would make that joke like me. But anyway, okay, so permutations have a formula. And first thing we need to talk about is what these N and R mean. And N is the total number of objects, and R is how many you're selecting. Now, my pen example was extremely basic because I had 4 objects and I selected all 4. So that math was 4 permutation 4, which is the same thing as 4 factorial. Okay, but there is a formula for this that we're going to use. And did anybody see my Google Classroom post already about the quiz topics? So these are on your next quiz. And I just wanted to show you the top of it, if I can find it. It has the formulas at the top. I was trying to comfort you in the fact that you do not need to memorize these formulas at all. I did copy it, I swear. I did. It's here somewhere in my giant stack of stuff that I have. But, oh, here it is. Okay, so take a look at this. This is the top of your quiz. And so it has the formulas on there. So we're going to write those on our sheet, starting with permutations. We haven't talked about combinations yet. Okay, so the formula is n factorial over n minus r factorial. And you're thinking to yourself, that's a lot of things to do with no calculator. But I promise you we made the math easy for you. Okay, so we're going to do number 1 and number 3 right now on these notes. Okay, so this is 6 factorial over 6 minus 3 factorial. And 6 factorial is 6 times 5 times 3 times 2 times 1. And I promise you, you're going to get to the point where you won't need to write that out, but we're writing it out right now. Yeah, what did I forget something? 4? You're the best. That's why I use the erasable pens. Okay, and then you guys, what is 6 minus 3? 3. Okay, so 3 times 2 times 1 on the bottom. Okay, are you with me so far? The whole point of this is to find stuff to cancel out. So cancel out the 1s, cancel out the 2s, cancel out the 3s. And now you have 6 times 5 is 30, times 4 is 120. And that's your final answer. So you could see most of the time you don't need the calculator, and we made it set up so that easy enough problems where you won't need it. Okay, now let's do actually, can you guys try number 3 in your groups? Okay, now for the lazy. I'm a lazy human being. So I see you cheating on the shortcuts in the calculator. Stop it. So their factorial button does exist on your calculator. Also, there's a thing where you can just type in the 6p3 and it will tell you the answer. Guess what though? You're not gonna have that. So, okay, but because I'm lazy, on number 3, I can visualize already that I'm gonna cancel out the 3, 2, and 1. Does that make sense? You know, I could just write from 12 to 4. But again, you can cheat if you like. Okay, so there's my first way to cheat. Um, Yikes. And then here's my set. I would never give you this one, by the way. This one's crazy town. There's the second way to cheat. Look at all the cheating. Isn't it wonderful? Okay, anyway. 1, 2, 3. So we have 79,833,600. Okay, now let's go over to what's the difference between a permutation and a combination. And it's really, this is going to be kind of embarrassing for me. So if you could just try not to judge me right now, that'd be awesome. I really appreciate you not judging. That's awesome. Super great. Just ahead of time, just saying. This is an example of a combination. Yes, yes, I have 4 pink pens. Okay. So combinations are groups of all the same thing. So for combinations, they're groups and if you can just isolate these words, different and same, and in math, you're supposed to say order matters and order doesn't matter, but that's really hard for people to understand. If you just think about it as, are these different? Are these the same? Then it's good. Okay, the formula for combination is n factorial over n minus r factorial r factorial. And the reason that the extra r factorial is there is because you're dividing out all the repeats, because the repeats don't matter anymore if they're all the same. So you have to think about it like this. You don't think about it like 4 colored pens. You think about it like 4 pens. In a combination, this is the same thing as this, is the same thing as this, is the same thing as this, which means you need to divide out all the repeats, which is why you divide here. Okay. So 6 combination, 3, 6 factorial over 6 minus 3 factorial, 3 factorial. And then you just cancel out as much stuff as you can. So I cancel out the 1s, 2s, and 3s over here. And then do you guys notice that this cancels out the 6? Do you notice that it cancels out the 6? Does anybody notice that it cancels out the 6? Okay. Try number 4 in your groups. I don't know about this one. You might need a calculator. We'll see. You can go check if you want. I'm almost done. Okay. Let me just try it. I don't know how bad this is going to be. Does my critical thinking make sense here? I did some critical thinking. Okay. I know. Weird. Okay. Moving down to the word problem. What we need to do is decide if it's a permutation or combination, and then find the number of possibilities. Okay. The student body of 100 students wants to elect a president, vice president, secretary, and treasurer. Okay, all you ask yourself is, are these things the same or different? These four things, are they the same thing or are they different? Different. That means it's a permutation. They're different things. It's a permutation. You have a total of 100 students, so that number goes here. And you're arranging four different things, so that number goes there. We might need the calculator here. Oh, wait, no, we should be able to cross this out everything under 96, correct? Yeah. A lot of ways. Okay. Next one. A group of 30 people need to take an elevator to the top floor. They will go in groups of 6. They're deciding who will take the elevator on the second trip. That doesn't really matter. Okay, we have groups. Are they all the same or are they different? Same. I even put the word groups in the thing above so that it would help you out. Same is combination. 30 people total, groups of 6. What's wrong? Are you guys debating the second trip? What do you guys think about number 7? Permutation or combination? What's wrong? No, it's stupid because you don't know. No, it's dumb. Like, Kuda puts that in there just to mess with your head. 24, because 6 of them are gone. That's not the answer in the CUDA thing.
And I don't know if it's because you can't tell who the six would be. I don't know. When you do, this has driven me nuts for 20 years. So you go into the CUDA software and they give you this problem, and then this is the answer. And I really want it to be 24, really bad. I promise you, I will not trick you in such a way. I guess it's just because they're like planning out each individual trip. It's not dependent on the fact that six are already gone. I don't like it though. This is the kind of stuff that we'll sit and talk about at lunch, like at links. Anyway, okay, 7, permutation or combination? Combination, great, great job. 19, 5. Okay, last thing. And this is another thing about CUDA that I hate. Uh, captain and co-captain, just to let you know, in terms of math, are different things. A co-captain is apparently beneath a captain, but if you have two co-captains, they're the same. So this is a permutation. I hate it. Okay, now your homework is weird. Can you guys find the next page in your packet, please? I suspect that you're not going to get the whole thing correct and be, I don't want to say that you're all not brilliant and wonderful children and students, but I have a feeling that a lot of us are not going to be able to break out of the escape room without some help. Okay, but let me explain. I just want you to do your best. Okay, so what's going to happen is find this guy. You're going to go to Google Classroom, and I posted this at 8:30. Nope, don't do it now. Don't do it now. You're just watching. You're just watching. You're just watching. Okay, and you're going to come up with this. It says, can you solve all the word problems and escape the museum? While on a field trip to the Science Museum, you and your friends decide to explore on your own, blah, 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 la, la, 12 clues, yada, 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 stuff, fun, good luck. Okay, now you come down here. There are 12 spots in the room where the cursor turns into a hand. Okay, so you see how like it's a point, you can't see it up there. Okay, but like, why can't you see it? No, it's like showing on my screen, but not yours. Anyway, you're gonna move the mouse around until you find where it's something you can click. And there's 10, 12 spots. So I'm gonna try to go, not this one. I'm gonna try to find number 1. Okay, number 1, by the way, is this like little fire alarm, the little red fire alarm in the top left corner. Do you see the little fire alarm in the top left corner on the yellow wall? Okay, that's number 1. I clicked it. You can't see it. Okay, it says, look, you found a clue. Record the answer to this problem for clue number 1. So you're going to look at box number 1, and it says,
A company wants to create as many 9-digit customer account numbers as possible without changing the first 4 digits. How many account numbers can they create assuming repeated digits are allowed? Okay, these are hard. You do what you can in box number 1 and then move on. Okay, at the very end, when you think you have all 12, and they're spicy. You go to the little, okay, do you guys see the column in the middle of the room? There's like a column that's going up to the ceiling. At the top of it, there's like a little 10 key pad. If you click that, that's the exit. So when you think you have all the clues, you exit there and it gives you a Google form. Then you put your name in and then you put your guess. That's the wrong guess. I was just playing with it earlier. But you guess whatever you got from clue number 1. And if it's correct, it lets you to the next one. And if it's not correct, then it says no, like this. Yeah, because I was just messing with it. Okay. I do not have expectations that this is going to be simple or done immediately, so it's okay. However, I still have some of your time. And I need to start the 10-1 through 10-6 thing because we're not going to be able to finish it on Monday. We're going to do the first little bit. I don't know if you guys looked at the assignment sheet.
Oh.
So just so you know how I'm breaking up the stamps, this page that we just did, which is the note, is going to be the stamp for the first box. So 10-1 through 10-6, I'll stamp in the next box. It's just a time crunch issue of being CPT day. I'm thinking we might get through the first 2 and then we'll do like 3 through 6 on Monday. I'm thinking. Okay, let me bring up the book. Okay, this problem always makes me super jealous. When Angela turned 18, her uncle Zachary explained to her that he'd been saving money for her college education since she was born. He told her that when she was 1 month old, he had put $50 into a safe deposit box, and the month following, he added 53. He continued adding money like this each month, putting in $3 more than he had the previous month. The money that he had saved would now pay for Angela to attend any college of her choosing. Is it familiar? Maybe. Oh, this part. Yeah, you're right. It's what we did on the warm-ups. Okay. Write out the amounts of the deposits for the first few months as an arithmetic sequence. How much was added to Angela's college fund in the 12th month? Okay, so we're actually going to write out the first 12 months. And N is the month number. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is when Angela was born. She's just a baby. She's got this super awesome uncle who has a bunch of extra money, apparently. And I know.
And the first month he puts in $50. And the second month he puts in $53 and he keeps going all this way till her 18th birthday. I never had a rich uncle. Just sailing down the student loan river of life, me for yeah. Anyway. And this doesn't seem so bad because, $74 a month, not that bad. But then when she gets to be, okay, now this part is definitely a math one. And we did those warm-ups. Hopefully this will help. First thing we're going to do is define an arithmetic sequence. An arithmetic sequence is a number pattern. And arithmetic sequences is very specifically adding the same amount each time. I do want to make sure that you understand when I say add, I could mean add a negative. They're not always increasing, but you can add a positive or add a negative. Okay, and let's define our letters. So D is the growth. And the reason that it's D is because it's difference. T0 is term 0. The equation is T of n equals D n plus T0. So y equals mx plus b. Okay, in this problem, in Angela's college savings problem, D is 3 because it's going up 3 each time. And term 0 would be the number in front, which would be what? 47. So the equation is T of n equals 3n plus 47. Okay, what is the equation good for? Now, if you remember back from math 1, we taught you explicit and recursive. This is the explicit equation. And the explicit equation, the best thing about it is to be able to find a number way down the sequence. Because we're too lazy to keep writing comma plus 3, comma plus 3. I don't know about you guys, I was done after like the first 3. So the explicit equation helps you get a number way down. Okay, this is, I think, the last thing I'm going to be able to do. We want to find the amount deposited in the last month of her 18th year. So I want to find the biggest amount he put in, the very last deposit he made. Okay. How many months would that be? 18 years worth of months. $216, excellent. So the best part about the equation is I can plug in 216 instead of listing out 216 numbers. That means that her uncle put in almost $700 on that last month. That's a lot. That's a lot. Okay, we will continue upon this on Monday. I'm going to be really excited to see how far you guys get on your escape room.